This screencast is about the quadratic formula. So there's a few things that you need to remember before using the quadratic formula. First of all, you need to have the quadratic form or the quadratic equation ax squared plus bx plus c equal to 0. It has to be equal to 0 before you can use the quadratic formula. The a variable is the coefficient of the x squared. The b variable is the coefficient of the x, and the c variable is the constant. It's just the number. Second of all, the formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It's going to be helpful if you write that formula down every time for every formula. There's a couple different songs that can help you remember the formula, but mainly it's just going to be repetition that's going to help you remember it. Once you've got these two ideas, then you can actually start using the formula properly. Before I start actually using the formula though, I want to kind of talk about when am I going to use the quadratic formula versus factoring or completing the square. I'm going to use factoring when I can factor. So if it's equal to 0 and I can factor, I'm going to try to factor just because I've had the most practice with it and because it's easiest to me. I'm going to use completing the square when the a value is 1, when the b value is even, and when it's equal, when the overall equation is equal to a number. Otherwise, I'm going to use completing the square, or otherwise I'm going to use the quadratic formula. So here I've got some large numbers. A is a big number, B is an even number, but it's still a large number, and C is a large number. My overall equation is equal to 0. This kind of makes it a good candidate for the quadratic formula, because I don't really want to multiply A times C and find factors that add up to 6. So I'm going to go ahead and just use quadratic formula. A equals 9, B equals 6, C equals negative 15. I'm going to write out A equals, B equals, and C equals every time. I'm also going to write out the quadratic formula every time. Okay, so now I'm going to actually substitute. Now I'm going to simplify. You want to make sure you keep your calculator close to you so that I can do negative 36 times negative 15. Since it's a negative times a negative, I'm going to get a positive 540. 36 plus 540 is 576. That's a perfect square. And it is 24. So x equals negative 6 plus or minus 24 divided by, 18. This is really two answers. I really have negative 6 plus 24 over 18, which is 18 over 18, 1. And I also have negative 6 minus 24 over 18, which is negative 30 over 18. Negative 15 over 9, negative 5 over 30. Since I have two rational numbers as my solutions, that means that my original problem was actually factorable. But I didn't really want to factor it. Large numbers, I just used the quadratic formula. But these are my two answers for x. That's what x equals. It was a quadratic, which means I had two possible answers anyways, so there's my answer. Okay, this problem, I'm going to get it equal to 0. Since these are pretty small numbers, I'm going to check to see if it's factorable first. Is there anything that multiplies to -7 and adds up to 5? No. I'm not going to use completing the square because my b value is odd, so I'm going to use the quadratic formula. A equals 1, b equals 5, c equals -7. Quadratic formula is x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So that's -5 plus or minus the square root of 25 minus 4 times 1 times -7 all over 2 times 1. That's -5 plus or minus the square root of 25 plus 28. So x equals -5 plus or minus the square root of 53 divided by 2. So I need to check if I can break down 53 into anything simpler. And I cannot, so that's my final answer. Remember, my two answers are -5 plus the square root of 53 over 2 and -5 minus the square root of 53 over 2. Okay. My next one, I have to get it equal to 0 first. So I want to add the 5x. I need to distribute the 2 so I can figure out what. And I need to reorder these, right? Because remember, the a value is in front of the x squared, the b value is in front of the x, and the c value is the constant term. Quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. 2 times -8 is -16. Is there anything that multiplies to -16 and adds up to 5? Nope, nothing that does that. So I'm going to use the quadratic formula. So x equals -5 plus or minus the square root of 25 minus 4 times 2 times -8 all over 2 times 2. So now I have 89 underneath the radical. That also does not simplify, so this is my final answer. Remember, if it does simplify, you want to break it down into a radical times another radical and reduce as much as possible. Number 4, I want to move the 25 over. This one only has 2 terms, so I need to figure out which one's A, which one's B, which one's C. So remember, A is the number in front of the x squared, B is in front of the x, and C is the constant. It's just the plain number. So in this case, I've got a number in front of the x squared, I don't have any number in front of the x, and I have just a plain number. So I have A equals 2, there is no B, and C is -25. In quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, the opposite of b is 0, then I've got 0 squared minus 4 times a times b all over 2 times a. So x equals 0 plus or minus the square root of 0 plus 200 all over 4. So here I need to break this into 100 times 2. Now remember, when I'm reducing, I reduce numbers on the outside of radicals with numbers outside of a radical. So this becomes 5 radical 2 over 2. And there's my final answer. Alright, in this case, I need to still get it equal to 0. So I'm going to distribute, and I'm going to subtract the 4x. So I've got 3x squared plus 6x minus 2. I'm also going to subtract the 4x, get it equal to 0. Combine like terms, make sure they're in the right order. So I've got 6x minus x gives me 5x. Subtract another 4x, gives me just a plus x, minus 2 equals 0. So now I've got a is 3, b is 1, c is negative 2. You might be saying that this one is factorable. I'm going to use the quadratic formula just to practice. So I've got negative 1 plus or minus the square root of 1, minus 4 times a times c, 2 times 3. So now I've got two possibilities. Negative 1 plus 5 over 6, which is 2/3, or negative 1 minus 5 over 6, which is negative 1. So those are my two solutions. Again, since I got rational solutions, that means that it was factorable. So I could have factored my answer, or my original equation here. Alright, last one. It's already equal to 0. I only have two terms, so I need to decide what's a, what's b, and what's c. A is the number in front of the x squared, so that's 3. B is the number in front of the x, so that's negative 4. And c is the just plain number. So what is just the number out here? There isn't anything, so it's just a 0. Quadratic formula is the opposite of b, plus or minus the square root, b squared minus 4ac, all over 2a. So that means I've got the opposite of negative 4, plus or minus the square root of negative 4 squared, minus 4 times a times c, all over 2 times 3. So x equals 4 plus or minus the square root of 16 minus 0 over 6 equals 4 plus or minus square root of 16 over 6. Got two answers again. 4 plus 4 over 6, 8 over 6, 4/3. Or I've got 4 minus 4 over 6, 0 over 6, which is 0. So, x equals 4/3 or x equals 0. Since I have rational solutions, that means I could have factored, right? The greatest common factor of 3x squared minus 4x equals 0 would be x, so I could have factored in the beginning.